We're missing Christina, Leif. Anyone else? Umit?
Umit might be a little bit late.
Okay, cool. Oh, I just saw your Slack message, Kit. Sorry.
What about the XRP poll Uri was talking about?
What was that, Valder?
The extra people that Uri was talking about, are they going to be joining?
I don't know. I didn't hear anything else about that after. I mean, they don't have the meeting info. No one asked me for it, so I don't know.
Yeah. We'll just have to divine it. I've got a Ouija board around here or something.
Ooh. Those are so effective. It's like astrology.
No, it's not quite as effective as my little Ouija board, though. It's much better.
Are jokes less fun for you to say if half the people are on mute and you can't feel their actual reaction, or you just say them for yourself, so it doesn't matter?
No, I can see the body language cringe on everyone's face, so it makes me just as happy.
Oh, nice.
Wait, does anyone play Mario? Can I continue to make Mario puns?
That's just a pipe dream.
It's because we're all cooped up.
I guess we'll give it a couple more minutes, or should we just start?
We can wait for the panicked email that says we can't join the meeting.
I forget which one it was. It was like The Onion or something like that, maybe, where there was an article where it was like Mario gives controversial interview defending Italy's actions during World War II or something like that. It was one of those fake news kind of things.
I think you mean alternative facts, Leif.
Yeah. No, the intentionally fake, like The Onion or like one of the joke ones. You know?
Is there really a line anymore?
Nah.
One of my favorite things in high school physics is we had to derive all of the physical laws of the Mario universe by like playing Mario and making observations.
Oh, nice.
Yeah.
That's a pretty good exercise, actually.
It was awesome. The only thing I remember about high school physics. There's no E and M though, which makes it sort of difficult. You can basically only do like classical mechanics.
Yeah.
There's no quantum in Mario?
Well, I guess we can't really know.
Can you tunnel through the flagpole, like quantum tunneling past the...
I've always assumed that the pipes are quantum tunnels, but you never know.
So like pixel entanglement?
Hey, you could make a new curriculum and one up my teacher. Oh, the cringes are excellent. This is good.
We'll be here all day.
Literally in this chair, not moving.
That's quarantine.
Hello.
Okay, well, I don't have any emails asking for the meeting, but I did send the info to Uri. You could pass it along
Okay.
if he sees it in time. I mean, the other people were Hillary. I guess I could text Hillary.
Yeah, I mean, the fact that we recorded is probably a plus. That way they can do the second consumption of this.
Yeah. I think we can probably just get started.
Okay. Everyone can see it?
Yes.
Cool. So today we wanted to go over NetTango and do an introduction to how to build it, because some of us are interested in it. In this talk, the four of us want to basically describe what is NetTango. I know you all read it, and so read the tutorial a bit, but just like what's going on there and where do we classify it. We want to do a workshop addressing some questions that came up, and then just kind of generally discuss NetTango and any other concerns or ideas you've had. I'll present what is NetTango, and then we'll be presenting 3 models and building together during the workshop. Then we'll have some time at the end for questions and discussion. So what is NetTango? To answer that, we kind of need to know what is programming. And so I'm going to throw out a working definition. You could punch holes in it and add bits and subtract bits, but a way to instruct computers to do certain tasks. But instruct a computer to perform simple tasks has 2 parts. You can instruct a computer such as set variable x to something else. Here we could iterate x plus 3. So that would be a simple task we can get a computer to do. Here we're doing it in a block-based language, but you could do it in lots of other ways as well. Perform simple tasks. Here we have 2 functions. If on the edge bounce, this would be for like a ball in a make-believe world, turn some amount of degrees. These we would implement in instructions, but they're simple tasks we could use in programming. So there's kind of 2 constraints here we're working with when we make a program. All programs must be written in a way the computer understands the instructions, and a human needs to understand how to write the instructions. So you have this kind of 2-part constraint. It's created a lot of diversity inside of programming and programming languages. Yeah, so these 2 constraints lead to high level, that means easy for humans to understand, and low level languages, that means very close to the instructions we're going to give to the machine. NetTango is a high level language. It attempts to be as closer to how humans do things and simple for them. So at the very bottom, you have machine language, that's an assembly language. These are things that give direct instructions to machines in the way that they can execute them. Then you have the high level languages. That means that a line of code expands into multiple machine instructions. So you have to break apart these instructions into bits parts the computers can implement directly. And so you have lots of examples of this. This is just my illustration of how NetTango sits, but C has derivatives, and you have Java going off another way. But here's some examples of some high-level languages: Fortran, the earliest one, and Pascal, and C, and Lisp, which got iterated into Logo and gets branched into Star Logo, NetLogo, Scratch, and now NetTango. So what is NetTango? In NetTango, we design blocks to be easy for humans to understand, but these blocks are far from what the computer understands. In this case, NetLogo code. When we design a NetTango model, we have to design mappings from the block to the underlying code. So we're trying to make things easy for humans to understand, but we go through this medium of code. So it's a way of approaching what humans want through block-based visual programming. You could define it other ways, but this is how I see it. So now we're going to move into the workshop time. We're going to have kind of 3 different sections. We're going to kind of, first I'll give a little tour of one model, just show you how it works, and then we'll have Connor, Sugat, and I each show you a model, and we'll all be programming together. And then we'll have a bit of time for discussion at the end. So here we have a particle sandbox that we've built for the theory grant. Right now we just have the particles. We created a model that has 92 particles with initial particle speed, no green particles, and no speed there. We don't have them colliding against each other. We just have a box that they bounce off of when they move. So we can give them another function, and we say check for particle contact. So we want to do something when they particle contact, and we're going to do some classic conservation of energy, which is all black boxed in this change speed and direction. So we would ask, oh, what happens when when you do that? So then we have these particles, and they start running into each other and bouncing off each other. And we can see a difference as we do. We could also put in stick, and we'll see agglomeration. So they start sticking together like, I don't know, gum or something. We could change the initial particle speed and the initial, and go again. Still see them sticking together and agglomerating, change speed and direction, get rid of stick. So what we see here is very high level commands that control these graphical turtles on the screen. And they go down through NetLogo down to the computer. So we can program these in what comes close just human speech, and it tries to go down so we can understand how to change the model, and it goes down to being compiled and run without having to get the syntax. Next up, we have Connor, who's going to give us building a model from the ground up. I don't know if you want to share your screen, Connor. What do you want to do?
Yeah, I'll share mine. So if you can stop sharing then.
Yeah.
Can everyone see my screen now?
Yes.
Yes. Okay. So if you didn't see it before, it's yelkey.com/reason ? I think was the keyword. If not, you can just Google NetTango Builder. It's the first result. And here's the web URL. So it's netlogoweb.org/ntango-build. So I'm going to go through just making a basic model that does turtle geometry. So we're going to have a turtle. It's going to be able to make turns. It's going to be able to go forward, and it's going to draw its path. So this is kind of like a typical first NetLogo exercise. Did everyone get a chance to go through the tutorial that got sent out about ants? I see some nods. I see some lack of nods. I'm not judging anyone, don't worry. Vouter is nodding in a circle, which I'm not really sure what it means, but we'll let it slide. So that's one way of going through basically kind of transitioning an existing model into a NetTango model. And if you've got a chance.
While Connor's doing this, if you want to program along, or that will probably reinforce your learning, also send questions in the chat doing this. If you're struggling with something, we're happy to sidebar any problems. So this is not supposed to be lickety split, but this is actually the workshop where we're building together.
Yep, so feel free to drop things in the chat. Umit, Sugat, anyone else who has NetTango experience can answer those questions. And if you want to follow along with what I'm doing, feel free to. If you want to just watch and you can follow along with a later one, that's fine too. We'll have everything linked. But as I was saying, so like the tutorial goes through how to take an existing model and sort of use the existing code and transition that into NetTango blocks. And as we said before, NetTango is sort of weird. It's sort of like a programming language in and of itself, but really the blocks that you make are written in NetLogo code. So you have to be able to design blocks that are representative of NetLogo code. And then when you use the actual NetTango blocks to create something, what NetTango is doing in the background is stitching together the code underlying those blocks into NetLogo code, which then NetLogo Web is running. So it turns out that it's a little weird to think about. And if you went through the ants tutorial, you might have found it's a little odd to kind of think about things in terms of blocks, but also in terms of code and how those two things portion out. So we're going to do one example of that with turtle geometry, which is pretty simple because turtle geometry doesn't have anything complicated. everything that we're going to use is already built in NetLogo procedures and commands. So we're going to use things like right turn, left turn, forward, backward, that sort of thing. All right, so first step. If you opened up this page and you already see a model loaded in, that's because you've seen this page before and loaded something in. So in this case, the last time I was on this page, I had the wolves and sheep demo model loaded. At the very bottom, you should see a little button that says load WSP testing defaults. So that loads in this sample model that's a wolf sheep model, which I think Sugat will talk about a version of later. So we're not going to cover the particulars of this. The important part here is that it does that because the NetTango builder is trying to be nice to you, and whenever you make some sort of edit or you start working on some kind of model, it saves your work to local storage in your browser. So that's so that you don't lose your things as you work. But in this case, we want to start from a fresh slate. How do I do that? I go to this Files menu, and I'm going to click Clear Model and Spaces, Clear All Data. So now I have a fresh blank NetLogo model and a fresh blank NetTango space down here. So this should look very familiar. This is just NetLogo Web right up here. Down here is where NetTango kind of lives. So the first thing we need to do is we need to create a block space. So a block space is a canvas where you drag and drop blocks, and that's where students will actually be constructing their blocks programs. So I'm going to click Add New Block Space, and just like that, I have block space 0, which you can name. So this is our turtle block space. And this space is where we're going to, A, define the blocks that the students can use, and B, actually compose programs using those blocks. Up here, we have this model. And these things are going to interact. So when I write something in blocks, it has to be able to be called by stuff up here in the NetLogo model. So we're going to start with the regular NetLogo paradigm of setup and go buttons. So I'm going to click on the lock to make this into authoring mode. I'm going to right click and create a button. First one, setup. So now I've got a setup button. I'm going to move it off to the side. Next one is go. Going to set it off to the side. So now I have two buttons that when clicked, those procedures will be called, right? So when I click the setup button, it's going to try to call the setup procedure. And the traditional way of defining what setup does is going into the code tab and writing a setup procedure. So in this case, we're doing turtle geometry. So I'm going to write a simple setup procedure that clears everything. So get rid of all my existing turtles. Create one turtle and ask it to put its pen down. So hopefully everyone's familiar with that. So what that does is create a single turtle, and it says put your pen down. So whenever I move, I'm going to trace your path. And then we're going to reset ticks because we're all really conscientious NetLogo programmers. The reset ticks is the end of all setup methods. So this is the traditional way of writing a procedure. And you can see now my setup is ready to go because I can call these things. So if I go back into interactive mode by clicking the lock, I can hit setup. I now have a turtle. It's got its pen down. I can't see its pen down because it hasn't moved, but I know its pen's down. That's the traditional way of writing a procedure, right? You write it in code. But for our Go procedure, we want students to be able to write the Go procedure themselves by using blocks. So instead of defining the Go procedure up top in the code, we're going to define the code procedure down here in the NetTango code. So the first thing we need to do is we need to add a procedure block. And this is going to be the first block in any kind of chain of blocks that says the following blocks are going to be the definition of this procedure. So I'm going to click Add Block, Basics, Procedure. I'm going to call it Go. It's type procedure. This limit says how many blocks of that type can a student add to the space. I only want one because you can only define a procedure once. And I'm going to name the procedure Go. And that's it. I'm not going to have any sort of parameters or anything like that. I just need NetLogo to know that there is a procedure called Go. So now if I were to drag this over here and hit recompile, you can see down here the code that's generated from that block. Is that too small? Can everyone see that? I'm going to make it a little bit bigger just in case. I don't know what happens when I resize my screen and screen sharing, so hopefully you can see everything. So now the code generated down here is to go, right? So all we did was create a procedure by creating a procedure block, a special type of block, and notice that you can only add things to the end of it. So you can't precede a procedure because you're defining what happens in this procedure by attaching blocks to it. All right, so now that we have that, what kinds of things do we want our turtle to do? Well, if we're doing turtle geometry, stepping forward is probably the first thing we want to do. So I'm going to make a forward block. Add block, basics, command. And the command for forward in NetLogo is either forward or just FD. But I want students to be able to control how far forward that this turtle is going to go. So I'm going to add a parameter. So you can see here it says use left brace, right brace with a number in between for parameter. All that means is that if I want a parameter, I do this. So this is going to be my first parameter, or my 0th parameter. And it says I'm going to feed that parameter into the forward procedure in NetLogo. And then you have to define what that parameter is by clicking add parameter. In this case, I'm going to call this step size, because it's how far forward the turtle will go. I'm going to put it in ints, which just means whole numbers. And actually, you know what? Instead of ints, why don't we do a range? So a range says go from this number to this number by however many units. So in this case, I'm going to do, how about -10 to 10 by ones with a default of 1. So the default is when I drag the block onto the space, what's the regular value that it shows? Step size says that I'm going to make available -10, -9, -8, so forth, up to 10. So I've created my parameter. I specified it in my NetLogo code. This is the 0th parameter. It's going to go as forward. I don't want to have any limit on this block, and I'm going to call it forward because that's what it is. So then I'm going to click add block, and you can see that I've now created a block in my block space. If a student were to take my block, drag it in, now I have forward, so my turtle should go forward, and then if I click on this parameter here, I can manipulate the value. Right, so it goes from -10 all the way up to 10. Great.
You don't have to embed that in some kind of ask.
Good point, Leif. Okay, so remember, in agent-based modeling and in NetLogo, whenever you're asking something to do a procedure, you literally have to ask the turtle to do that procedure. So if I actually try this and call go, what's going to happen? So go is an observer context because go is turtle only. So I said go, and then I added this block that was a turtle block. Forward only applies to turtles. So I need to get this go block in some sort of ask, right? So the easiest way to do that is click add block. And then if we go to control blocks, there's an ask turtles block. And if I click this, it will fill in all the usual stuff that you might need, because this is going to be a special type of block that looks much different than the 2 blocks that we've already seen. So a procedure block only allows things to be connected to its tail, right, its bottom. And then the command block can be connected on the top or the bottom. But an ask is a weird thing where you're going to be putting things inside of that block, because the ask is started with a left bracket and ends with a right bracket in the text language. The synonymous part of that in blocks is that it's going to have a kind of a top brace and a bottom brace. That might be hard to envision, but if I have this ask turtles block, if I pull this over here, now you can see any block I put inside of ask turtles, that code gets inserted inside the ask turtles text-based command. So now I have my ask turtles, so thank you, Leif, for pointing that out. And now, if I recompile, and I click setup, and I hit go, it should ask my turtles, which there's only 1, to go forward. Hey, check it out. Hooray. So now, what are other things we want to do? Well, maybe we want to do right turns. So again, this is the same simple thing as forward, because right turn and forward are pretty synonymous. You're just going to feed it a different parameter. So add block, basics, command. In this case, I'm going to do right turn. I'm going to add a parameter. I'm going to call it turn right. I'm going to add my parameter down here. I'm going to call it turn angle. I'm going to make it a range. Yes, Mandy asks a good question, which I will attend to in 1 second. And I'm going to label it degrees, unlimited limit, add new block. I now have a turn right block. It's going to look similar to the forward block. And if I click in here, I can manipulate the degree parameter from -90 to +90. So Mandy asks, so this is a design decision, right? The ask turtles could have been within the forward command. This is a good point. So this is kind of synonymous with how we would program it in a text-based NetLogo format. If I was creating this model in text NetLogo, I would write ask turtles, and then I would embed those commands within the ask turtles. What Mandy is pointing out is that, say we wanted to make this a little simpler for our students, or we wanted to kind of abstract away the idea of asking things. You could come back to your forward block, hit edit, and instead of saying just forward, you could say ask turtles forward. In that sense, ask is no longer in a block, it's a kind of part of your forward block, right? So this is a design decision. And this is where it kind of gets tricky with designing a NetTango model, because you have to decide what's going to be kind of exposed via the actual block and what it looks like, and what's going to be internalized inside the blocks. And if you were in the CCL research, I don't know what quarter, last quarter I think, where I talked about some NetTango models for CTT STEM classes, a lot of those are about kind of abstracting away programming detail, where the programming detail gets hidden inside the actual code within the block. And then you're exposing certain types of logic by creating those types of blocks. So good question, Mandy. Yes, it is a design decision that gets very confusing as you design more and more complicated models. So for now, we're going to stick with trying to make it look exactly like text-based code. Another question?
NetLogo also does that all the time. It uses primitives. So like forward, for instance, is a fairly complicated piece of code, but in NetLogo, we have a primitive called forward. So in that way, you're always doing this at higher level languages of inventing ways of saying things you're doing all the time and taking away the complexity for the user.
Yep, so great point. So again, you're kind of designing your own programming language, which if you've never done it before, gets very complicated very quickly, I promise. So as you can see, we now have a way of drawing, for instance, a square. If I set it to 90 degrees, if I set it to something like 60 degrees, I should get a different shape, right? So if I set it to some other sort of degrees, I can make the shape bigger by saying, oh, I'm going to make this slightly larger. Great, so we can make all sorts of shapes. And then remember that although we're defining the go procedure down here, the setup procedure is defined in code. So say I wanted to change the number of turtles I had to 10. So now I should have, well, after I recompile and click setup, I now have 10 turtles. So now I'm going to have 10 turtles that all make this shape. So let me hit go. Now I start to get some weird designs, right? And all we have to do for all this sorts of turtle geometry is make other commands available, right? So turn left, there's no difference between turn left and turn right blocks, because you can just make a turn left block and do left turn and make it look exactly like that. In fact, if I go to modify block, turn right, I can duplicate that block, then modify the second one to be turn left and make this LT, hit update, boom, left turn block. So I can make something even weirder by saying maybe left turn 10, 9, turn right 60, setup, go. So now I'm going to get something that's not necessarily a regular polygon. Make sense? The only other thing that I wanted to quickly cover, because this is kind of the basics of taking a NetLogo procedure that already exists, for instance, right turn, and turning it into a block, so that instead of having to type something out, you're dragging and dropping, right? So really, we're kind of creating a one-to-one correspondence between the NetTango model and the NetLogo model, with the convenience of not having to know NetLogo syntax. Instead, you're just kind of dragging and dropping things in. In this sense, it's more like, if you're familiar with David Weintrop's work, it's more like a hybrid language, where you're sort of creating a text-based program using these blocks. That's not the case with all NetLogo models. It just happens to be the case with this example. The only other thing I wanted to do is do a loop. So again, a loop is similar to an ask, where it has defined boundaries, and then you need to repeat the things within the boundary a number of times. So how do you do that? And how do you design a block that says, let's loop these commands inside of this thing over and over? Well, if you go to add block and you look at basics, there's no loop there. If you look at control blocks, no loop there. If you look at global commands, no loop there. If you look at turtle commands, no loop there. So how do we do a loop? Well, a loop is just like, in a kind of a weird sense, looks in blocks just like an if statement. So an if statement says something happens and then we go to the blocks inside of this if statement. A loop is the same sort of thing. It says, once I reach this point, I'm going to execute the stuff inside of me over and over again. So weirdly enough, I'm going to make an if block, all right? And I'm going to get rid of this if and just say repeat, and then a parameter for the number of times. And we're going to call this loop. And it's technically an if block, but we're going to be using it for repeat, because all we need is the structure of the block that says, I want to be able to put blocks inside of this kind of macro block. Again, no limits. I need to add a parameter. So we'll call this num times. And this needs to be an integer because you can't repeat something a partial number of times. We'll make the default 5. We'll click add new block. So it looks like a loop over here. When I drag it over here, it's a block that contains something. This is the parameter about how many times that thing will happen. And I can drag whatever I want here. So if I want to go forward 1 and then turn right inside of that loop. So now after completing turn left, forward 9, turn right 60, it will repeat forward 1, turn right 10, 5 times. So if I come back up here, click setup, click go. Now I'm going to get even different shapes. And I could theoretically change this turn angle. What will happen? Get even weirder shapes. All right, so that's basically how to create this kind of one-to-one correspondence of text NetLogo, because this looks very familiar to those of you who have programmed in text NetLogo. And in fact, if you go down and look here, this is basically exactly what you would write to make this in text. It's a little friendlier interface. It's more kind of graphical about its structure, right? So instead of using braces, you're actually seeing physical indentations and physical contains in these blocks. So really, at this point, you're just kind of utilizing blocks as a friendly way of not having to know syntax and not knowing how to have to change the inputs to or parameters to a function. So this is one approach to creating a NetTango model. There are more complicated approaches, and usually it depends on how you want someone to interact with your model. So unless anyone has any questions about turtle geometry in NetTango, yeah, Sugat, go.
Is it worthwhile? I mean, I'm just asking NetTango users and others who want to weigh in. Is it worthwhile adding like a default block which is repeat rather than, so making a suggestion to Jeremy that having, because repeat is one of the fundamental things. I don't know whether we should call it loop or repeat. I would side on calling it repeat, but having something like that as a default block.
I mean, something I've wanted for a while is a checkbox that says forever on a procedure, so I can make any procedure a forever loop. Just like the go button is a forever loop in normal NetTango, it would be nice if I could make a procedure forever.
I think there are benefits to having it not be a button, but actually like a code block, because I feel like that seems more like text-based code. It was one of the things that I found most tricky about using NetLogo to begin with, because like I was like, why are there buttons that are different from code? And it was weird toggling back and forth. I kind of like the fact that it's explicit in the code.
Yeah, so part of the reason that NetTango gets confusing too is that even if you, so for instance, we defined the procedure go in our NetTango block space down below, right? So we have a button that calls go, and then we use NetTango to actually define what that go procedure does. And that's sort of kind of that idea of interacting with a NetLogo model using the buttons to call procedures is still sort of a fundamental part of NetLogo. And Sugat, in answer to your question about loops, part of the reason this kind of is technically difficult is that some buttons can be looped in and of themselves. So then the question becomes, where does the loop go? So in most NetLogo models, a lot of the time, the loop is not inside of the code. Instead, it's a button-based feature. And that is not common of any other programming language that I know. So like, there's this weird dichotomy between there's logic in the interface of the NetLogo model, and there's underlying logic in the code. It's sort of like how plots logic is inside of a plot in NetLogo, not inside of the code tab. So there are these weird kind of dichotomies that, I mean, they've made these choices to make things kind of like make the mental model of how this model is working a little bit easier to think about. They've kind of abstracted away certain levels of detail in order to make this easier to think about. It's like plotting is separated. But then again, it makes it a little weird when you're trying to kind of expose the underlying detail with NetTango. So then you have to make, again, these design decisions that say, what part am I going to expose? What part am I not going to expose? So that's why, so like, if you have trouble designing a NetTango model, think about the next level where if you're designing a builder to build NetTango models, there's design decisions at each of these different levels that become increasingly more confusing. John Chen's got a question. Seems that there should be a visual cue in NetTango's Go block if the button is a forever one in the block. Yeah, so in this particular case, the button logic is always up here in the NetLogo web portion. So if I make this Go button a forever button, just like in NetTango desktop, or sorry, NetLogo desktop, there's a little rotating thing here that says it's forever, and it would be depressed as it runs. Not sad, but you know, like actually pressed in. And that is not particularly clear down here, right? Because it's not saying that Go is being called over and over again. But again, this becomes a question of where does that logic get notated? This is just a definition of a procedure. It doesn't matter how many times this gets called or what it gets wrapped in, right? This is just saying when Go gets called, this is what gets executed. So there's really no way of telling this Go button, for instance, if it was hooked up to this, that it should loop based on what's down here. So again, this is where it gets sort of complicated, and then you have to make a decision about where to notate those sorts of things. So that was very confusing. I apologize.
No, that was great. I think we should move on to Sugat's part now, for sake of time.
I agree. Roly-polies are cooler than turtles anyway.
Hot take.
Okay. Yeah, so I will try and share my screen. I'll do the desktop. Oh. Can you all hear me okay and see this okay? Okay. So before we dive into, oh, there are comments. Oh.
It's on the previous stuff, so I'll answer those comments and you can keep going.
Okay. So NetTango is being increasingly used in CT STEM lessons, and I'm going to give you a quick example, a quick idea about 4 places where it's been used, and we will delve deep into one of those. So these are the 4 that I am aware of, and there can be more, but it's cool that since the builder is available, we are having it integrated in more and more number of lessons. So the first one is ecosystems, which is building the classical NetLogo model, prey-predator relationship, where students put blocks together, coding for behavior of a predator and behavior of a prey, and see how populations fluctuate. The other one is an experimental biology unit about roly-polies, and that I will explain in more detail. The third one is something that Umit has worked on, and related to what Kit showed earlier, which is this gas sandbox where you're coding behavior of a particle and observing the emergent effect regarding pressure, temperature, and things like that. The fourth one is a physics model that I worked with a teacher in India, which is about free fall. So it's not really a multi-agent model. It's coding behavior of an agent, which is a free-falling object. But it's a cool thing that she wanted to teach her students, and they were coding basically free fall Newtonian mechanics of the ball. So after they have understood the idea, they were making sure that their model is doing what how a ball would do in the real world. So let's delve deep into one of these examples, which is roly-poly. Can you see the presentation mode? Okay, cool. So I don't know, depending on time, Kit, you can take that call after a minute, whether we want to split into 3 groups and each group would work separately on their models, or we can just do it together. But before that, I'll just give you an overview. So this was a AP biology class about animal behavior and experimental design. And a teacher at ETHS developed it with us. So she used to conduct this physical lab where they would collect these roly-poly bugs, put them together in these petri dishes and observe their behavior in terms of preference, which chamber they prefer. So one chamber would have a different condition than other, like dry and moist. And they would observe behavior of these bugs in the lab and then do statistical testing, whether there is statistically significant difference in their preference for chambers and things like that. So this year, this academic year, students did this lab, and in addition, they did a computational lab, which was designed in 3 phases. So they first explored a NetLogo model and observed behavior of these bugs, which were already pre-coded in the model. Then they changed the model and tried to integrate additional concepts. And finally, they constructed the model. So this sort of is what Feynman said about modeling, right? If you have understood it, you can model it. And if you have really understood how sort of the circuit of roly-poly behavior would work in terms of an behavior of an agent, you could potentially code it and get similar kind of emergent effects. So we are going to play with this model that was built. So earlier Connor showed you how to build a NetTango setup. Now this is a pre-built NetTango setup which can be used to code a model. And so Kit, do you think we should do it in groups or we should do it together?
I think we should do it together.
Okay, cool. So this is the L key around. And I hope all can open it on your screen. I will give you an initial demo of some very basic activities, and you can try and create a challenging situation. So this already has set up and go buttons, but those need to be specified here. So setup button would add roly-polies, and if you do that, you get 10 roly-polies. If you, I mean, depending on the number that you add. But these roly-polies need to be in a chamber. So you can create a and this is the chamber. You can make it smaller or bigger. You can move it around by changing X and Y. And you can clear so that every time you do it, it doesn't create problems. So now just everybody spend a couple of minutes and try to create chambers like this, where you have two chambers which are interconnected and you add roly-polies in the center. And if you finish, you will demo it to the rest of the class. So please raise your hand if you have finished creating two chambers that look like. Okay, Jacob, I will stop sharing screen, and can you share your screen and explain how you did it?
Okay. Okay, they're not exactly the same size, but I have a clear buck to just clear whatever was there before. And then I'm creating two different chambers. And the first one, I don't know why the X now looks like this, but the first one starts at negative, the center's at -8 and it has a radius of 9. And the other chamber has, whoops, same radius of 9, but the center at +8. And so they both overlap a little bit where they touch in the middle. And then I add roly-polies in the center. And I don't know how to make them different colors the way you had them.
Okay, no, so that was a NetLogo model where there were two colors. But okay, this is great. So now can you add a Go block and ask roly-polies to go forward? But don't do it yet. And anybody has a prediction what would happen? Okay, what will what will happen, Jacob?
They're just going to start moving forward. If the go button is repeating, they'll just move forward outside of the chambers probably.
Yes. So in this case, as you see, the go button in the model is running forever, right?
Yeah.
So, yeah. Can you press it? Yeah. So they just move out of the chamber. Now the task for all of you is to make sure that they move inside the chamber, and their movement is more or less realistic. They're not just moving in a straight line. So everybody just play with the go blocks and make sure that their movement is realistic.
Sugat,
Yes.
can I ask a question?
Yes.
Why did you use that? It's a very different strategy. Usually we have the blocks such as wiggle or wander. Why did you decide to use turn right, turn left, max angle?
Yeah, I don't that's how it was done in the NetLogo code. So that is another thing that we should talk about, how we convert these models from one to other. But yeah, it is another design choice which could be done differently.
And from a pedagogical perspective, I seem to remember Teresa wanting them to look into the code tab. Is that correct, Sugat?
Mm-hmm.
So like if you create something that looks totally unfamiliar to what they would think or look at in the code tab and not be able to see, then you're kind of not encouraging a transition from blocks to text. So if you want to encourage that transition, then you should plan for it. And if you don't want to encourage that transition, it's a design choice you have to make.
Yes. So anybody other than Jacob, when they finish it, please demonstrate to others. Just raise your hand.
Do you want me to do it?
Yes, please, Gabi.
Okay. Okay, can you guys see this okay? So I had a similar setup to Jacob as far as the chambers. Mine are just slightly larger and slightly distanced. To make the roly-polies look like they're moving a little bit more realistically, I originally had the go forward and then, I guess that should be before, but some wiggling and then going forward. And then I wanted them to basically not go in the dark patches. So I added the if I'm facing a dark patch and just change direction. I did 90 degrees just because that's what was in the block. And then I popped the normal movement in the else. So then it looks like this. Just wandering around and bouncing off the walls.
Cool. Thanks, Gabi. So in this class, students were asked to do this kind of stuff where they were building model. But now you realize that these blocks are not enough to build this completely. To make sure that you have modeled the roly-poly behavior. So as the last thing that I'm going to quickly show is when you can have a completely pre-built NetLogo model, and then you can just add a few more blocks and students can code those blocks. So that is a different strategy that can be used with NetTango. So to control roly-poly behavior, you're going to use yell key control. So yellkey.com control. I'm going to share my screen. Where there is already an existing NetLogo model. Okay, and you can set up conditions in the chambers like moist versus dry. You can set number of roly-polies. You can set preferred condition for roly-polies. You can update those conditions. And then you get readout of number of roly-polies in chamber 1 versus number of roly-polies in chamber 2. And now you can code behavior of roly-polies. So behave like roly-polies and move. You move in a specific way And if you are on a preferred patch, there is a chance that you would move. And if you're not on a preferred patch, you would move with a different probability. Does that make sense? So in order to mimic roly-poly behavior, can someone suggest what values should be set for these blocks?
So if they're on a preferred patch, they should move with a much smaller probability than if they're not on a preferred patch.
Yes. So if they're not on a preferred patch, they should, the probability that they move should be higher. And then, so it's a very, sorry, but you have to set conditions accordingly. So it's a very simplistic way of thinking, but basically you are coding behavior of a roly-poly so that finally you would end up seeing a lot more roly-polies in the preferred chamber as opposed to non-preferred chamber. And then you can play around with these parameters, make it more or less less distributed differently. Okay, so I haven't set it up in a way such that I would show you how each of these blocks were coded, but this was more for you to give a flavor of how NetTango can be used for educational purposes in different contexts. So I'm hoping that in the next session, Kit would give you some idea about what kind of code goes in these blocks. By the way, one thing that all students see how these blocks, that they code with these looks code in NetLogo. That is another feature that allows students to sort of think from block-based to text-based and how it would work. And it's interesting that there are some students who like to look at the text more and who thinks that they're like CS student, they would want text. So some other interesting insights can be derived regarding student learning and so on. Okay, so I'm going to stop and hand over to Kate.
Hey, Sugat, didn't Dave Weintraub talk about that, where like some kids just never got over the hump of thinking that it was like quote unquote real coding to do text-based, but not real coding to do block-based?
Yeah. And I think some of the data from NetTango CT STEM lessons can be used because we have asked students questions regarding blocks versus text, and we could get some more insights regarding that.
Yeah, we have anecdotal evidence that same sort of thing happens in our classes.
I feel like it's not real coding if the text is not green and the background is black.
All right, so we're going to move on from there in the sake of time. Thank you so much, Sugat. That was great. So we talked about turtle geometry and the roly-poly ones. I just want to give you the possibility to edit a model and also how to save that work out. So when you're thinking about a lesson, you can do that. So if you can go to ccl.edu/theorybuilding. And we're going to scroll down here, and this website I've enabled with hot linking and the deployed models. Basically in the disease model, if we click disease model, we'll see the roly-poly model as kind of the built model, the deployed one. You can't edit these blocks. It's protected from any kind of change, and you don't get the authoring environment. But the editable model is a hot linked model. So you get into the authoring model with the ability to edit these blocks, as Connor was saying. So we can build off this model just like we're building from scratch. So in this model, it's trigger warning, it's about disease spread. We have a person who's sick, they wander around. If they're infected, if they touch someone else, they infect them 100% of the time. These people don't get better, they just stay sick, they don't die of it. This would be a pure endemic. So number of people and then your population, and in the theory grant, we're looking at this pattern, how that changes. So you can do some other things like if sick, recover some percentage of the time. And then if sick, die some percentage of the time. And we can recompile and see what our new model does. In this case, they'll keep going. We're losing people as they go. It looks like the sick is going to wipe out basically the whole population. And there we go. We've burned out the virus and it's gone away because of some reason. But we may want to edit this model, and we certainly, if we edit this model, want to save this model. So if you go to this web link, you can save your work out. You can add models to this space with safety. Like, you can't change what's on the server. It's completely protected. But you can edit these blocks as you would, and you can save that file out, and you can use it later. So you can make your own version of this model. So for instance, let's do a basic one. So we're just going to try to, set the color of the turtles to a different color. Let's say it's yellow. I don't remember if I did ask turtles in the blocks or if we did it in code. So we'll see if we run an error, but let's see. There we go. So now we've changed the color of all of them in their a cosmetic change. But we could also ask, we could do something more meaningful, such as changing the breed of the turtles. Well, that's going to be a little confusing, but we can do that. So NetLogo command, we have 2 breeds in this code. We'll add another one, which would be breed dogs, dog. This doesn't have any code to it, but we can still have it. Basic commands. Didn't give it a good name. We'll just do it in here. What did I do wrong? I don't remember.
Looks like we're missing an opening bracket.
Yeah.
Oh, yeah. So we've done some kind of dramatic changes. We can also do the color one, so on and so forth. But if we close this web page right now, this would all disappear into the ether. So we could be editing and creating as long as we wanted, but we couldn't do anything with it. So in order to save our work, we need to do two things. First, we need to export the NetTango project. And what this is going to do is make a JSON file of it. You can just imagine this is the save file. You can put it on the ground, and we can say this is yellow turtles. And then when we want to come back to our work, we'll save that in an appropriate place. When we're going to come back to our work, we could import that NetTango model, which is on the desktop, yellow turtles. And as you notice, the model, when I reloaded the page, it reverted back to the beginning. And so but when we open this, we will get, or you'll get just a random error. I don't know why that is.
Quick note. So Sugat showed us an exported version of a NetTango model that was in an HTML file. So it's a standalone file where you can host it on a web server and students can interact with it. And that's what we do at CT STEM mostly. That being said, when you export an HTML file, although it embeds all of your NetTango blocks in it, it is no longer editable at that point. So you can't add any blocks or remove any blocks. And secondly, it is not easy to recover the blocks from that HTML file back into the NetTango editor. So if you're working on a NetTango model, you should do what Kit did, which is export the NetTango project and get that empty JSON file, in addition to exporting that preview HTML page. That way you can have still access to the blocks you make and be able to edit changes. Otherwise, you have to go into the HTML file, get the blocks back, put them in your own JSON file. It's not worth your time. So make sure to export the empty JSON and the HTML file.
So there was some compiling error, so I'm demonstrating to you again how to do this. Hopefully it works this time. Okay, I do not know why that is running like that. I've never seen that error before. So I will check with Jeremy, but that would be how you go about it. Sorry about that. I'll keep futzing with this and I'll get it to work. I will demonstrate it. So now we're going to spend the last 20 minutes, and I want you to tinker around with one of the models, make your own turtle geometry model. You can go to the theory website and play with one of the two models I've built and put on in the editable version. Just see what you can do and surface any questions you want. Also, discuss whatever features you like at this point, and we'll just mix and match. This kind of open workshop session. If you want to post in the chat which model you're working on, that would be cool. So I figured out how to do it. I don't know why it was throwing that error before, but so I saved an earlier version of it after adding the blocks. I import NetTango project, yellow, and then it imports. If you want to export your saved HTML, as Connor was mentioning, you just say export standalone HTML. Then you can go to your desktop and open that in any browser. As he was saying, this is completely uneditable and hard to extract the block from, but you get that deployable model. You can embed this in a web page and all that sort of thing. So this is kind of the production level one you would show to students.
Yeah, and one other comment on exporting HTML. So on the NetTango Builder page, there's an options button. It says options ... If you click on that options button, a lot of those things have to do with what your model will look like when you export it. So you can hide different parts of the model, like you can hide the code tab if you don't want students to look at the code. You can hide command center if you're not going to use it. You can change block style, like default block styles, all those sorts of things. So you can very much customize what you want it to look like when a student actually uses it. So those are all in the options tab. And those get saved inside of your NetTango JSON file. And then when you export to an HTML file, those options are used to create that HTML file. But again, save it as an NT-JSON file, not as just an HTML file.
You also get these fun styling blocks, so you can style the entirety of all your blocks of a certain type in here, which is super useful because sorting blocks by color, such as procedures, commands, control blocks, is very helpful visually for the user of these in the models. So consider these in your model and how they fit in and how they help highlight the functions of your model.
Just on a side note, I'm playing around with the disease model, but the if sick infect block talks about recovery. That's something you might want to change.
What so the if sick, what happens?
So it talks about the chance of recovery. So the label there is wrong within the block.
Oh, which one is that?
The default one that loads, so if sick.
Infect.
Yes, sorry.
Oh, here, yeah. That makes sense. Copy and paste error.
Also a very different question.
Yeah.
How does the scalability of this translate to NetLogo? Because I'm making a 3,000 agent model and it's slow.
Yeah, NetLogo Web is slower than NetLogo Desktop by a lot. So yeah, I try to keep all these models under 500 agents. And patches are really inefficient, it seems, so I try to keep the patch count down. It's a browser-based thing, so it's just a lot slower.
Yeah, you didn't hear this from me, but if you're using a model with more than 500 agents or 500 patches, NLW is going to be really slow. But again, I didn't say that.
And it really matters how much you're executing per patch, per turtle, per tick. As long as you don't have a lot of special stuff, it can be okay. But if you have a lot of if conditionals, you run every single thing on every single tick on every single agent, it's going to bog down quick.
And that includes set of procedures. So if you're making, like setting the color of a patch and you have, say, 10,000 patches, you will notice.
I don't have something based on radius right now, but let's break this thing down.
Yeah, in radius, they've made it more efficient, I think, a year and a half ago, but it's still that's a real performance killer.
Web apps are slow.
I got a question for those of you that have used multiple NetLogo or NetTango models. Since every model, in a sense, like you're making a new programming language, you're defining primitives. Do you think there could be an issue where, like, in one model, like the turtle geometry one, yeah, the students actually have to ask turtles, and they're dealing with more primitives? Then maybe they use a different NetTango model, and over there's no ask turtles. You just directly drag a block that says move. Do you think there's any concern that students could start getting confused because of those sort of inconsistencies across NetTango models?
Yes.
Yeah, I don't think we have reached to that level of NetTango, but you're right. I mean, we should be careful. We should have like some emergent design principles to convert NetLogo to NetTango.
Yeah, for internal stuff, I mean, we can be consistent about things, but again, it depends on what part of the tool is it's supposed to be, it's allowing you to design in objectives for students to learn. So like in several of the models that we created during CTSI over the summer, we were designing a pathway for students to move from blocks-based to text-based. That's not necessarily true of everyone, right? So like in connected chemistry, there's no idea of switching from block-based to text-based. The block-based is purely meant as a way to be able to quickly interact with a model, build and interact and test a model. So there's no pathway outside of that. So yeah, I mean, it's a good question. It's like if you're presenting it as a programming language, that like any other programming language, like Scratch, for instance, if you learn how to read one Scratch model, or whatever they call it, Scratch mixtape, I forget what they call it, script, then you can read another Scratch script. That's not necessarily the case with NetTango. NetTango is not technically a language. It's a mapping from NetLogo code to NetTango to visual blocks. So one of the dangers here is that, say we have teachers build NetTango models, if they don't understand that distinction, then suddenly that distinction can kind of percolate down and become even more confusing. And then you could be endangering the whole, like, oh, it's not really a programming language, it's these blocks things, and you're actually making that true as well because you're kind of putting this wrapping on top of it. And
I mean, I think it's not as a huge danger as long as you realize NetTango are kind of a genre, and we're kind of inventing the genre now. Like, these are science domain specific modeling environments, and each one has its own language, and you need to, like, as a designer, create it for the audience and the purpose of this curriculum because it's domain specific. But also you build it, if we want to build on what has happened before, that's why I think it's really important to share these hot linkable, editable models so that the next person can copy what we, like, learn from what we did, and we can be sharing that as builders. But you're going to get motifs and genres as we go along here. Just like with video games, you kind of know how to use one if you've used the next one because the next person builds off what came before. So it depends on what happens here as we expand. But I think people are inherently lazy and they're going to copy code that is available. So if we provide nice examples, I think other people will follow suit. So I think we have like 6 minutes left. Does anyone want to screen share what they've come up with or talk about things they ran into? We want to also have a conduit back to Jeremy with what came up here. So if you have design or development things that comes up when you're looking into it like this, we would love to hear that as well. But if anyone wants to volunteer to share what they built, that would be an awesome constructionist thing to do.
I don't have much to share, but one thing I do want to mention is I found the parameter setting extremely difficult with these sliders. The fact that there's not an option to type in values if I have a slider, it was annoying when I first started working with it, and I'm now pissed off about it. So it escalated pretty quickly.
So you mean when you're using a range parameter, you can't type it in? Okay, gotcha. Yeah, and part of that is that is not the case in NetLogo, right? So if you have a slider in NetLogo, you can type in the exact value you want. That's a good point.
Exactly.
Yeah.
Yeah, for example, I wanted to put if seek infect at 1%, and I freaking couldn't because my mouse sensitivity didn't allow me to, and there's no way I can get it on 1.
One workaround for that is that you can make a NetLogo slider that's a global variable, and then use that global variable as the parameter for your later command.
I could also change the block and make it default set to 1, but I mean,
all true.
But as a student, you wouldn't have any of those. So if you had just the HTML version.
When I was going through the tutorial thing that you sent beforehand, Kit, there was one typo or error in the instructions. So I don't know who I should tell about that.
Me.
Okay.
Please pass on any typos, any vague sentences, anything that really bothered you with the tutorial. Just send me an email or on Slack. I will really appreciate that.
Okay, cool.
Also, those who have built models with NetTango, you will notice that at the bottom, we have 2 example models, but we want to expand on it. We want to have more example models for people to be able to both tinker with, but also download and edit. So just send over.
Any other questions or comments?
Question: if we found a bug in NetTango, should we tell you guys or just tell Jeremy or Jason or who?
If it's in the actual program, tell them. If it's in one of our models, let us know.
Okay.
It's Jeremy mainly.
Yeah, and he just got back onto full time.
if I for some reason delete a block from the library, can I get it back?
No, it's gone.
Ooh, that's rough.
Yep. You can reload on any of the hot linked models. You can just reload the model, but if you're building your own, yeah, destruction is permanent. So save your work regularly.
I don't think there's undo either. So
Not really, no. It should be. And you can't copy and paste easily using Command C, Command V, which also should be.
Yeah, I have a question, maybe for Kit or for the group. Like, I could hear Kit you saying that you want a lot of people to be involved in the process of building NetTango models and not just using those. And in comparison between NetLogo and NetTango, how robust do you think it is? And especially from the CT STEM point of view, what we haven't really envisioned students building NetTango models. Students using NetTango to build models is what we have been doing. But building NetTango models is even coding those blocks which you were showing, which is a layer below. So comments from you or anybody else in the group?
I think that's an admirable goal. I think that that's not currently feasible. I don't think it requires enough specialized knowledge where I think right now it's not feasible to ask a student to do it.
But why would we have a student make a NetTango model instead of just making a NetLogo model?
So I did this like 5 years ago with VMAP, and we had students first use a VMAP ants model for 6 months where they just kind of test it, gather data in it, learned about ants, changed the block parameters, learned different life cycle things. But at 6 months, the teacher wanted to do some service work, and so she did a capstone with it. And she had the 8th graders redesign the model for 4th graders and then go to the 4th graders school and teach them using the model they designed. So when they did that, they added a larger life cycle, more predators, changed around parameters, and it was a design project for the 8th graders. It was very successful. It got the 8th graders really engaged in it. The 4th graders liked it. We had this peer learning moment. But I think it takes, like, they were in the Java and in the NetLogo after 6 months doing this. But it took 6 months of wrapping their head around it, like twice a week. So is it feasible all the time? No. Is it awesome? Yeah, it was really cool.
Any last questions, as it is 3:30?
All right. Thank you all so much. This has been really cool. Please send any and all questions or comments to any of us who have done it. Happy to share and show.
Thanks
Yeah,
for
thank you guys
organizing.
for doing this. It's really helpful to do this and be a part of the workshop. So thank you.
And next week, we'll actually learn how to tango.
Except you can't touch your partner, Connor.
I don't know how to tango. I won't be dancing.
Looked like you were slow dancing during the CT STEM meeting. You were like rocking back and forth for a bit.
I'm totally normal, Leif. Okay, leave me alone.
Yeah.
All right. If no one has any questions, I think we're good to go.
All right.
Everybody take care. Be safe.
Bye. Thank you.
Bye all. Stay
Thanks.
safe.
Take care, everyone.
Thanks, buddy.
Bye.
Bye.